Today we are going to discuss the second part of the code conversion program, in which we will be discussing the code conversion program, that is binary to ASCII and ASCII to binary. So before we are going to discuss the program, it is better to discuss what is ASCII code. This is actually an American Standard Code for Information Interchange, and this code is normally used for the communication. So whenever we have a binary number, it has to be converted into the ASCII code. So actually it is a 7-bit code, and related to every alphanumeric number, it has a certain code. So if the number is from 0 to 9, the code is represented as, the ASCII code is represented as 30 to 39. It means if the binary, if the value in the decimal is given from 0 to 9, if we add 30, we can get its ASCII code. But if the letter is from A to Z, it is represented by 41H to 5AH. Therefore, it is considered that if the numbers are from 0 to 9, we have to add 30, and if the number is greater than 9, that is from A, B, C, D, E, F, we have to add 37. So the sample, some example has been shown that if the number is 1, what will be its ASCII code? The ASCII code will be 31. If the number is 2, its ASCII code will be 32. But if the number is 9, the ASCII code will be 39. But if the number is A number is there, then this ASCII code will be 41, because since the number has been greater than 9, so instead of adding 30, we will add 37. B, it will be represented by 42. So this is how we have to write a program so that we are able to convert the binary number into the ASCII code. So whenever we have to convert the binary number into ASCII code, and we have two options. Options means whatever, it depends upon what number has to be converted, whether it is a numeric number or it is a alphabetic. If it is a numeric number, we have to add 30. If it is alphabetic, then we have to add 37H instead of 30. So of course, for this program we will be using some subroutine, and with the help of that subroutine we will be doing it. And before we are using subroutine, we must do the initialization process of the stack pointer, because whenever we are calling subroutine, there will be a program counter content which is which is the address of the next instruction after the subroutine, must be stored in a stack. So that is why in the store program, first of all, the stack pointer is initialized with SP is equal to 27FF, and then we have initialized the HL pair register with the source memory pointer, because source memory pointer will be having those 8-bit digits which has to be converted into a ASCII code. And then after conversion of the ASCII code, we have to store the number, so we have to initialize the D pair with the destination memory pointer. And since there are such 5 8-bit numbers which are available at a certain memory location from 0850 onwards, so we have initialized the counter C register as a counter in the form of a 05. If there are 4 numbers, then we will initialize it by 4. So first of all, what we are going to do, we are going to store the number into the accumulator, which has to be converted into an ASCII code, and then we restore that number in a B register. The purpose of restoring the number will be understandable later on. I will give you the explanation why we want to save that byte. So the first number is available in accumulator, and it is also available in the B register. So the process is very simple. Suppose we have a number 9F which is stored at a location 0850, and this 9F is now available in the accumulator. So whenever we are converting this 9F into the ASCII code, so 9 should be separated and F should be separated, because if 9F is there, so F will have its own ASCII code and 9 will have its own ASCII code. So the first of all, we will out of this 9F, first we will work on 9. And for working on 9, what we have to do, we have to shift the content of accumulator. We have to shift the content of accumulator into the to the right hand side, so that the right nibble should come to the so the leftmost nibble should come to the right side, and that is why we have used 4 times RRC instruction. Whenever 4 times RRC instruction is being used and 9F is available in the accumulator, when we will shift it 4 times, so what will become? It will become F9 in the accumulator, and then we will call the subroutine, and this subroutine will be converting the number into the ASCII code. So whenever it is calling the ASCII, so we will directly jump from call instruction to the ASCII. Now what is written in the ASCII? ASCII is written, the first instruction written in the subroutine is ANI 0F. Now 0F stands for 0000 and 1111. It means the number which is stored in the accumulator, which was 9F, after the rotation it becomes F9. What we want to extract 9 from this F9. It means we want to work with the most significant 4 bits, most significant nibble of the number. So what we have done first of all AND operation, just to mask the upper nibble, means we want to mask the F and we want to use only 9. So that is why we have used ANI 0F, mask the higher order nibble. After masking the higher order nibble, we have to check the value which is stored, which is less than 10 or less than 9. That is why we have used the instruction CPI. If the value available in the accumulator is less than 10, then we add 30. If it is more than 10, we will add 37. So since in this particular case 9 is the value, so 9 will be less than 10. If 9 will be less than 10, then carry will be generated. And if carry is generated, it is jump on carry next, it will coming to the next. What is happening in the next? We are adding 30 into that. And whenever we are adding 30, so the value in the accumulator will become 39. And then it will return. And it will return to which place? The place from where it has been called. The place it has been called, it was call ASCII. And just after the next instruction call ASCII, that is STX, it will return to that place. So where we are going to store the value. So where we are going to store the value? It will store the value of accumulator, which is 39, at what place? At the in the memory location, whose address will be defined by the DE pair. What is in the DE pair? DE pair is having 0860. So 0860 will store 39, which is the ASCII code of 9. Now still we have to find out the ASCII code of F. So for that, now the next value has to be stored. So for that we have increment the pointer register, that is destination pointer register, by INXD, so that INXD and D pair will be having 0861. And again we will call the ASCII. When we will call now, before we are calling the ASCII, there is one more instruction, move AB. Now what is B register? The actual number, that is 9F, was we have stored, we have saved it in the B register, and we call that number again into the accumulator. So when this number is called back to the accumulator, accumulator will be having 9F. And whenever we are having 9F, so what we will do, we will call the ASCII code. When it is calling the ASCII, it will again coming to the lower side where the ASCII label is defined, and again we are going to do the AND operation with 0F. Now with this we want to mask 9. So with the help of 0F, we are able to mask the 9, and the accumulator will be showing only 0F. Now 0F is greater than 0A. So it will not jump to the next. What it will go? It will add first 7. The next instruction, that is ADI 07. So 07 will be added into the F. So 07 will be added, and after that we were adding 30. So actually we are adding 37, but we are adding 7 first and 30 later on, and then it is going to return. And whenever it is going to return, it will be coming to the STXD. STXD pair is already incremented in the previous case, so it will become 0861, and at 0861 the content of accumulator, which is the ASCII code of F, will be stored. Now when it will be stored, the second number is stored, means 9 first 9 is 9F, out of 9F first 9 is converted into ASCII, and then F is converted into ASCII. And after that the D pair will be incremented by 1 INXD, so that it will become 0862. So the next number will be stored in the 0862. Now after doing that, we are again storing the number B into the accumulator. Now STXD पे जब हमने जब सेकंड वाला कॉल किया था तो STXD पे जब आया और INX-H कर दिया, तो INX-H कर दिया तो हमारा HL पेयर पहला नंबर ले रहा था. अब H वाला जो इंक्रीमेंट हो जाएगा एंड H वाला इंक्रीमेंट होकर के अब 08 जो हमने इसको किया था 0850 अब 0851 यानी नेक्स्ट नंबर अब पढ़ा जाएगा. उसके बाद हम क्या कर रहे हैं, डिक्रीमेंट C कर रहे हैं, यानी काउंटर की वैल्यू अब एक कम, क्योंकि एक नंबर हमने ASCII में कन्वर्ट कर दिया. डिक्रीमेंट C कर रहे हैं और फिर जंप ऑन नो ज़ीरो बैक और फिर बैक पे चले जा रहे हैं. बैक पे जा रहे हैं, फिर से यही सारा काम होगा फॉर द रेस्ट ऑफ द 4 नंबर्स. पहले नंबर पढ़ा जाएगा, उसके बाद नंबर को सेव किया जाएगा, उसके बाद 4 RRC इंस्ट्रक्शन यूज़ करके हायर निबल को पहले राइट हैंड साइड में लाया जाएगा. उसके बाद ASCII कॉल किया जाएगा. ASCII कॉल करने के बाद चेक किया जाएगा कि ये नंबर जो है वो 10 से बड़ा है कि नहीं. अगर 10 से छोटा है तो हम केवल 30 ऐड करेंगे, और अगर 10 से बड़ा है तो हम पहले 7 ऐड करेंगे, फिर 30 ऐड करेंगे और फिर रिटर्न करेंगे और फिर उसको उसी तरह से स्टोर करते जाएंगे. सो दैट इज़ हाउ दिस कन्वर्जन प्रोग्राम ऑफ ASCII कोड फ्रॉम बाइनरी टू ASCII इज़ बीन डन. नाउ दिस इज़ द एल्गोरिथम विद विच वी हैव रिटन द प्रोग्राम. सबसे पहले हम वी स्टोर द नंबर इनटू द एक्यूमुलेटर, वी ट्रांसफर द बाइट. Suppose the byte is 9F, so we will convert that 9F into first 09 and then 0F, and then we will call the subroutine to convert each nibble into the ASCII hex code, and then we store the number at 0860 and 0861. Now this is the program description. The first one is the main program transfers the binary data into the accumulator, which is the purpose of the main program. Then it shifts the higher order nibble to the lower order nibble, call the conversion subroutine, and stores the converted value into the memory. It retrieves again the same byte and repeats the conversion process for the lower order nibble. So in this program, masking instruction is used only once, ANI instruction is used only once, and with the help of that we are able to do the operation twice. Now the second program, which is related with the ASCII to binary, which is the counterpart of the binary to ASCII. In case of binary to ASCII, we are adding 30 and 37. In case of ASCII to binary, whenever we have to convert, we will subtract 37 or 30 depending upon the value which we are getting. If the number is from 0 to 9, we will subtract 30. If the value is greater than 9, then we will subtract 37. तो सबसे पहले इसमें इस प्रोग्राम में क्या किया गया है, सबसे पहले ASCII जो नंबर है जो कि अवेलेबल है 0850 HL पेयर को उससे इनिशियलाइज़ कर दिया गया, और जहाँ पे हमको रिजल्ट को स्टोर करना है दैट इज़ स्टोर्ड इन द D पेयर. उसके बाद हम काउंटर इस्तेमाल करें, कितने नंबर्स हैं जिसको हमको कन्वर्ट करना है, वी आर यूजिंग अ काउंटर. ऑफ कोर्स देयर इज़ अ मिस्टेक, इट शुड बी MVIC बिकॉज वी हैव टू यूज़ C रजिस्टर एज अ काउंटर. और सबसे पहले हम पहला नंबर पढ़ेंगे move AM and we will call the binary. तो बाइनरी में क्या है, पहले वो 30 सब्सट्रैक्ट करेगा. 30 सब्सट्रैक्ट करने के बाद हम चेक करेंगे कि ये 10 से बड़ा तो नहीं है. अगर 10 से बड़ा होगा, अगर नंबर 10 से बड़ा होगा तो कैरी जनरेट नहीं होगा. तो इसका मतलब है कि उसमें से 30 हमने सब्सट्रैक्ट किया है, हमको 7 और सब्सट्रैक्ट करना है. सो और अगर कैरी जनरेट हो रहा है इसका मतलब 10 से वो छोटा है. तो अब नेक्स्ट इंस्ट्रक्शन लिखा हुआ CPI 0A के बाद RC मीन्स रिटर्न ऑन कैरी. अगर कैरी जनरेट हो रहा है तो रिटर्न करेगा, और अगर कैरी जनरेट नहीं हो रहा है तो फिर वो नेक्स्ट इंस्ट्रक्शन पे आ जाएगा. तो कैरी कब जनरेट होगा, कैरी तब जनरेट होगा जब वैल्यू जो है वो 10 से कम होगी. जब 10 से कम होगी तो हम 30 सब्सट्रैक्ट कर चुके हैं, इट विल रिटर्न सो इट विल स्टोर द नंबर, एंड देन वी विल इंक्रीमेंट द डेस्टिनेशन पॉइंटर, इंक्रीमेंट द सोर्स पॉइंटर एंड डिक्रीमेंट द काउंटर. यहाँ पे भी DCR-D की जगह DCR-C होगा, प्लीज़ करेक्ट इट, एंड देन जंप ऑन नो ज़ीरो बैक. तो ये फिर से बैक जाएगा, दूसरा नंबर पढ़ेगा और दूसरे नंबर के साथ वही करेगा. लेकिन अगर हमने CPI 0A करने के बाद अगर रिज़ल्ट हमारा 10 से बड़ा है, यानी A है या B है या C है या D है या E है, तो उस केस में वो रिटर्न नहीं करेगा. वो कहाँ आएगा, फिर उसमें से 7 सब्सट्रैक्ट होगा, और 7 सब्सट्रैक्ट होने के बाद फिर ये रिटर्न होगा. सो कहने का सिर्फ पर्पज़ ये है कि अगर if the number is lying between 0 to 9, we will subtract 30, but if the number is lying in between above 9, so it means we are going to subtract 37. So addition is being done in the two way. पहले 30 ऐड किया गया, फिर 7 ऐड किया गया. सिमिलरली जब हम ASCII टू बाइनरी कर रहे हैं तो पहले 30 सब्सट्रैक्ट करेंगे और फिर 7 सब्सट्रैक्ट करेंगे. इट हार्डली मैटर्स. सो इन दिस वे द ASCII to binary to ASCII and ASCII to binary program is being done.